sinusoid. So we've talked a little bit about some of the stuff. I've tried to introduce it to you before and talking about phase shifts. And so the best way I can kind of do this is refer you to page 375, and I know I can't pull this up in the video, so if somebody has to watch this, then they really do need to be in their book for this. So we know the difference between a cosine function and a sinusoid function in terms of those waves, right? And so what we've looked at so far already is that we can change the center line, correct? So we can move it up or down on the y-axis. That's all we've done so far. What we're going to do today is looking at moving it or shifting it on the x-axis, okay? So you can look at, they give you several different sinusoid functions on page 375, and we could look at those and make sense out of them, right? You could look at that top left one of that 4 that are in the middle and see that that's a y equals 4 sine theta, right? It crosses through the origin. It has a amplitude of 4. It's positive. It uses theta, right? We get that so far, right? The one to the right of that, negative 3 sine theta, crosses through the origin. It has a negative amplitude, goes from 0 down to negative 3, so we get negative 3 sine theta. So everybody, if we understand this, then we're going to understand what's going to come next, okay? I just want to make sure that we get this. Right below that, you see y equals 2 cosine theta. Right, it crosses at the y-axis, has a positive amplitude, 2 on the y-axis, uses theta, and then your next one, y equals negative 4 cosine theta. But if you look down at the next one, right, the very bottom one, you'll notice that the maximum, the peak on it, isn't on the y-axis. And you'll also notice that as it increases, it doesn't cross through the origin. So because this doesn't appear to be either a cosine function or a sine function, this is what we're referring to as a phase-shifted sinusoid. It's been moved either to the left or right, okay? So the paragraph above that reads, the value of the sinusoid does not have to be 0 or its minimum or its maximum value when theta equals 0. The initial value can be any value between the minimum value and the maximum value. Observe this curve. All right, so this is, if you look where it's reaching its peak at, where you see it reaches 1 at, is actually at 45 degrees. Okay, if you follow the peak down to the x-axis, you're going to see it at 45 degrees. Do you follow me? Very bottom one. Here, I'll kind of walk around the room here a little bit. Notice that as you look at this peak, right, it's at 45 degrees where it peaks at, right? Do you have your book? Yeah, they're in the closet there. So where it peaks at here is at 45 degrees, okay? All right, so we're going to flip over here. We're going to go over to the next page. We're going to talk a little bit about that particular picture that you saw at the bottom of page 375 and how we're going to be able to write the sine function for that. So what it says here, it says we want to remember that the graph of any equation in x and y can be translated 2 units to the left by replacing it with x plus 2. So that x plus is going to move me to the left, x minus is going to move me to the right, correct? Right? We've done that before. We've seen that with different functions, like we've seen it with this, right? We've seen it with this, right? If we want to move something to the right, right, we're going to do this. If we want to move something to the left, we're going to do that. Okay? And let's see, the other one we have is absolute value of x, right? And I can change which way that function is going to move by either saying x plus or minus. Okay? Plus takes me to the left, y, or minus takes me to the right. You might be able to. His question was whether or not you can graph a sinusoid function. Yeah, you should be able to. All right. So remember that that plus or minus is either to the left or right. The independent variable in the equation, y equals sine theta, is theta. That's independent. Replacing theta with theta plus 45 will shift the graph 45 degrees to the left. When theta equals negative 45, the curve has the same value as a sine curve would have when theta equals 0. We say that the phase angle of this sine curve is negative 45 degrees, but we're going to write the argument with the negative of the phase angle, so we're going to end up with theta plus 45. That's why it's moving me to the left. Okay? When theta equals positive 45, you see the opposite take place. Okay, the curve of the same value that a cosine curve would have when theta equals 0. So the equation of this curve has a cosine function with a phase angle of cosine theta minus 45. So we can write a phase shift as either a sine function or a cosine function. Okay, that's where it gets a little complicated. Now, the most important thing that you come across whenever we're reading through these things is your bolded section. Right? If you don't understand something in a lesson, go back to the bolded section. So if you go down to this, right, it says, thus we note that the phase angle for a sine curve equals the angle nearest the origin where the curve crosses its center line on the way up. All right, so if you go back to page 375, the place where it crosses the x-axis closest to the center line is actually negative 45 degrees on its way up. Do you see that? Okay. So the phase angle for a sine curve equals the nearest origin where the curve crosses its center line on the way up. So if we were writing the sine function of this, we would look at that sine negative 45. So it would be, you know, sine parentheses theta plus 45 degrees. You follow me? Okay. The phase angle for a cosine curve equals the angle nearest the origin where the curve reaches its highest point. Arguments are written as theta minus the phase angle, so an argument of theta minus 45 indicates a positive 45 degree angle, and an argument of theta plus 45. So if you go back to page 375, on the cosine function, we're looking at where it reaches its peak at. It reaches its peak at 45 degrees. So we're going to say theta minus 45 degrees. So cosine theta minus 45. Okay, where that theta minus 45 is in parentheses. You with me so far? Okay. All right, so that's, and then you see below that, you see two pictures. One is describing what we're looking for from that chart on, or from that sine function on page 375, how we would write it as a sine function, or how we would write it as a cosine function with a phase shift. Okay? Now that seems somewhat complicated. And then from there on out, they're going to talk about the period of a sinusoid. So what I've mentioned to you before is that the natural period of a sinusoid is that it's going to go through a complete period in 360 degrees. But we can stretch sine functions or cosine functions or compress them. So we can go through an entire period in less than 360 or more than 360 degrees. Okay? So by looking at that, that's 57b. And you would put, and you know, if we go through, basically, if we went through two periods in this, let's see, I'm trying to find an example of this. Look at page 378. Okay? There's a picture at the very top of it. Notice that this is a sine function that is crossing at 0, 0. It's positive, and it's going through 1, 2 periods in 360 degrees. So we write that, and we put that 2 in front of my function variable. So in this case, it's theta, right? If it went through 4 periods in 360 degrees, we would call that y equals sine 4 theta. Okay? If it went through only half of its period in 360 degrees, we would say y equals sine 1/2 theta. Okay, so the number or the coefficient to theta is telling me what my period is. Okay, now if it goes through it in a perfect 360 degrees, the coefficient is 1 and we don't have to put anything in front of it. All right, so you see 1 there at the top of page 378. You see another one there just below that. It goes through 4 periods, so it's a y equals sine 4 theta. And then we see one where it's stretched out directly below that, where it doesn't complete its period till 720 degrees, so we get y equals sine theta over 2. Okay, is any of that over our heads? Go ahead.
Okay, so the one that doesn't complete its period until 720.
Yeah.
Why is that theta over 2?
Because it's only completing half a period in 360 degrees. Yes. Yeah. Okay. All right. So let's come up here and let's actually look at some of this. And so I like to try to keep things in order so I know what to deal with one thing at a time. Okay? I'm going to try to find my information here. And so I'm going to make a list of stuff that we need to address. The first thing is center line. Okay? Amplitude. Function. Period, and phase shift. Or CAF PP. CAF PP. That's the order that it goes essentially from left to right. Okay? CAF PP. Okay? So we want to write the equation for the sine function. All right, so for the sine function here, notice that it looks like a cosine function. Okay, so it's been shifted. Does that make sense? Okay, so let's start with this. The first thing that we want is we want the center line. Where's the center line for this at? Considering that each of these dots represents 1. 1, 2, 3. So you're saying the center line is right here? Center line. I haven't sent it to you? I'm pretty sure I did. I sent it this morning. Maybe I didn't. Oh, it only has the numbers? Okay. Let me pause this so I can get the document sent. All right. So what you should see is that the center line is -2. Right? Is that what you...
That's what I meant. It looked like that was -3.
Okay. The next thing we need is our amplitude. We should be going up, correct? All right. So our amplitude is what? Okay. All right. So +2. Okay. Oh, hold on. Actually not listing an amplitude here. I don't know why that is. Well, let's hold off on this. I think on like when it's a phase shift, because it can be shifted, they don't necessarily address the amplitude. But our function is what? Because they want it to be a sine function, it's sine. Okay? So the next thing is we need to look at our period. Okay? The period is 2 pi. So they tell me that to begin with. So is there a period change here? No, there's no period change because 360 degrees is 2 pi. And if it hits its period in 360 degrees, there's no change to the coefficient. So what I have in here then is I need to be able to address the phase shift. Okay? So on a sine function, we're looking at where it crosses here at the origin. So it's at this first notch. I know that's hard to see because my marker's really kind of too big. But we want to notice first off that it is hitting its period in 360 degrees. So what each of these marks represents is 90 degrees. Okay? Or maybe closer to 45. Let's see. Well, look at it. 1, 2, 3, 4, 5, 6. Let's see, what's 360 divided by 6? 60 degrees. Okay, and that's what's hard about these pictures. They're pretty hard to read, but what we should get out of this is that it's been shifted. It has been shifted 90 degrees, so we should get x plus, and because we're back behind it. Okay, the closest spot to our center line coming up is right here, so that's pi over 2 is 90 degrees. Okay, and the only reason we left it as pi over 2 instead of x plus 90 degrees is because when you look at the question, it says the period is 2 pi, so it's in radians, so our answer has to be in radians. Okay, does that make some sense? In all honesty, the questions that you get in your book are a lot clearer to get than these questions that are on these documents. Okay, because they're going to show you, what these marks represent, whereas on this document here, all they're giving me is marks, and sometimes they're filled in, and sometimes they're kind of empty, and they're not telling you exactly what each of those marks represents, which is a little frustrating. All right, and so if you look at question number 2, it's actually, you would end up with the same graph as graph number 1, right? Because it's, you'll notice that it's the exact same. Okay. So let's look at question number 3. Question number 3, match the graph with the correct function. Okay? All right, well, what is the center line here? -1. All right, so we've got y equals -1. And we are going to use a sine function here because we're going to consider the shift. Okay. Otherwise, we would say this is -1 cosine x, right? But we don't see a -1 plus cosine x, do we? All right. So we must be dealing with a shift. All right. So we're going to do -1 plus sine. Okay. The period is 2 pi, so I don't need to put anything after sine and before x. Okay, so we're going to have this. And essentially it's the same thing. It's been shifted back 90 degrees, right? So that our second tick mark, if each of those tick marks is whatever it comes out to, I should get x plus pi over 2. Okay, that same shift. The only thing that changed here between this and the one we saw in question number 1 is the center line is different. That's all that's different here. All right. You okay, Dylan? Yeah. All right. Let's see. Let's move over to question number. Oh, let's see. Did I miss question number 4? I guess. It says graph y equals -1 cosine parentheses minus 2x. If this is our interval. So looking at this, is there a phase shift in question number 4? No, there's no phase shift. The only thing that they're doing there is what? What are they applying? A period change, right? So if we were to look at this, if I've got this and let's say, here's 360 degrees and we wanted a cosine function, right, with a negative, it's going to cross at the origin, but it's going to have an amplitude of -1. So we've got -1, +1, okay? That what I want is something like that, so that I'm actually completing my period in 180 degrees, and so I'm completing 2 periods in 360 degrees. Okay, does that make sense? You with me? Okay. Okay. Back in the back, does that make sense? That's all we had to do. Which part of it do we not understand? Because we seem a little frustrated. So our amplitude is -1, so it's a negative line function. They did not change the center line, so my center line is at the origin, or sorry, is at 0. Okay, so then that means I have, and granted, my peaks don't go quite up to 1, but if the center line is here, if I'm going down at -1, then I got to go all the way up to 1, right? Which means I got to complete that period in 180 degrees, all right, and then get back and complete another period in another 180 degrees. Okay. All right, let's come over here. Graph y equals 2 cosine 4x. All right, so again, this is a period change. What does 2 represent? Yep, what is 2?
Oh, 2 is the...
No, not the center line, the amplitude, right? The center line is always something that's added to or subtracted from the total function, okay? So 2 is my amplitude, so we know that if we've got a cosine function with a maximum at 2. What is the center line based upon our equation? 0, okay? 0. And what does the 4x tell me? So how many periods am I going through in 360 degrees? 4, all right? So 2 pi represents 360 degrees. So as I look at this, you know, if I'm here, then I should be getting 1, 2, 3, and completing in the fourth one in 360 degrees, right? This 1, 2, 3, 4 is showing me how many I'm completing. Okay, so you don't count where you start from, okay? You count where you finish to. So that's how we get A as an answer. If you look at B, you'll see that 1, it's been shifted, right? It's not necessarily a cosine function, right? Neither is C, really kind of neither is D. The only cosine function you see up there is A. In addition to that, B has an amplitude of 4, so they're using the wrong 4, right? And they're only completing what looks like 2, so they're mixing their 4 and their 2 on B, and not giving you a cosine function. On number, let's see, on letter C, I think they go through 4 periods, but they use they've got a different center line. D's got a different center line. So there's a lot of reasons why B, C, and D are wrong. Okay. All right. Now, this is where we switch from lesson 57 to lesson 58. This stuff I think is a little bit easier. It says the distance from a point to a line. Okay, we want to find the distance from the point 6,5 to the graph of -6x minus 2y plus 3 equals 0. It does involve several steps. And then you got another one for 7. And then 8's graphing a parabola. So kind of go through this, and then 9 we'll get back into some other things. All right, finding the distance from a point to a line. The shortest distance, and we've dealt with this, I want to say in geometry, even on your last test. If you remember Michaela and, was that geometry, right? And we're trying to find a distance from the road to the radio station and the shortest distance and all of that kind of thing, right? It's the exact same thing, but the only thing that they're doing here is they're giving you the equation in standard form instead of y equals mx plus b, right? Which isn't really all that hard to change, but it does need to be changed. Yeah. Yeah, it's not a great question, or at least not one of our favorites. Okay, so I'm going to put this information up here. Let's see, we've got 6,5, and we've got -6x minus 2y plus 3 equals 0. So let's start off with this. Obviously, what I would do is I would add 6x and subtract 3. So you got -2y equals 6x minus 3. Divide by -2. So you got y equals, what, negative 3x? Let's see, plus 3/2. All right, so what we want to do with this is that the shortest distance between a point not on a line is going to be a perpendicular line, right? All right, so the first thing I'm going to do is I'm going to look at this, right? And I need one. I'm going to need to use 1/3. All right, but I need to find the equation of the line that uses 1/3 and this coordinate. All right, so for that, we're going to do y minus y1 equals m times x minus x1. Right? So we're going to use y minus 5 equals, we're going to throw in our slope, 1/3, x minus 6, solve this. So y minus 5 equals 1/3 x. 1/3 times negative 6 is negative 6/3, which is negative 2. Minus 2. Add 5 to that. So y equals 1/3 x plus 7. So now I have two equations, right? I've got the equation of our line, and I've got the equation of the perpendicular line that goes from that point to that line. Did I mess up? Oh, goodness. Yeah, you're right. Is 3, right? Did I get it right that time? Okay. So the nice thing about this is that the first thing that we need to find is we need to find the coordinates where these two lines cross, right? And so what that is, that's the solution of two linear equations, correct? So all I really have to do here is take this equation and this equation and set them equal to each other. So 1/3 x plus 3 should equal negative 3x plus 3/2. Okay? Let's see, let's subtract 3/2. Let's subtract 1/3 x. Okay, what's 3 minus, well, it'd be 3 minus 1.5, right? So I should be left with 1.5, or 3/2. What's negative 3 minus 1/3? Probably what? Negative 4/3? It'd be negative 3 1/3.
It'd be negative
10/3, negative 10/3. All right, so we've got negative 10/3 x. At this point, what we're going to do is, because we want to solve for x, we're going to multiply by negative 3/10, correct? Okay, so that's going to give me what? Negative 9/20. So x equals negative 9/20. I know this seems like a lot of work, but do we understand the work that we've done up to this point? So far, all we did here was convert to y-intercept, okay? We used point-slope formula over here to find the equation of a new line. Step number 3, solve for x, setting those two equations equal to each other. Okay, the only reason that this step looks so hard is because it was involving some fractions. Okay, if we wanted to get rid of those fractions, we could by multiplying everything by 6. You want to see how that would work? No? Okay. If I took all of that and multiplied by 6, it would cause all those fractions to become whole numbers. Because 3 and 2. Okay? Because if I multiply this by 6, right, I'm getting 18 divided by 2. Right? 18 divided by 2 is 9. If I divide that by 6, I'm getting 6/3. That's going to be equal to 2. And all the whole numbers are going to stay whole numbers. Okay, so I find basically a common denominator to my fractions and multiply by that whole number. Does that make sense? I would still end up getting negative 9/20 out of it though. Okay, it just maybe wouldn't feel so hard. Okay, x equals negative 9/20, and so we're going to pull this down. The next thing that we need to do is shove negative 9/20 into one of these equations. Doesn't really matter which one. Let's do y equals 1/3 times negative 9/20 plus 3. We'll find out what y equals. Okay, 1/3 times negative 9/20 is going to be like negative 9/60 plus 3. So at this point, I'm going to say use your calculator, right? Take 1 divided by 3 times negative 9/20 plus 3, and I get 2.85 or 57/20. Okay? 57/20. All right. So those are my x and y coordinates where these two lines cross at. Now, my final step in this is to find the distance from that point to our original coordinate, right? Because I believe our question is find the distance, right? So, yeah, we'd use the distance formula, right, where we're taking, let's see, with 6, 5, we would do 6 minus negative 9/20 squared plus 5 minus 57/20 squared. And you can answer this, I believe it's a decimal. I think I can probably plug all of this in our calculator in a single shot if I do it right, and it looks like my calculator is gone. Okay, square root 6 plus 9 divided by 20 squared plus 5 minus 57 divided by 20 squared. Hopefully that worked. I got 6.8. Did you guys get 6.8? Well, then you're wrong, because your answer should be 6.8. Yeah, to do it right, there's a lot of double parentheses that have to be set up to do it in your calculator. The only maybe better way to do it is just go ahead and do it section by section in your calculator, you know, and then rewrite your distance formula out with better numbers so you don't have as many parentheses to mess with. Right, but we should get 6.8 in that. All right. We may not have enough time to do another whole one, but we're going to try. Because you guys are going to get tomorrow to work in class. All right, number 7. It says find the distance from 1, -4. And we've got negative 5x plus 4y plus 2 equals 0. So what's the first step? Anessa, what's the first thing you're going to do with this? The x's and the constant, because we want this in slope-intercept form. So how do I move that negative 5x over? Add it. And how do I move the 2 over? Subtract it. All right, so it's going to give me 4y equals 5x minus 2. How do I move the 4 over? Divide by 4. So we get y equals 5/4 x minus 1/2. All right, so that's our first equation. Okay, Dylan, what comes next? This is step 1. What is step 2?
Find the inverse of the slope that you, the equation that you just found.
Okay, so we want to use what for my slope from this?
Negative 4/5.
-4/5. Okay,
Plug the coordinate that it gives you into the point code.
so let's do y minus what?
-4.
Okay, so I'm going to write that as y plus 4 equals what?
-4 is x minus 1.
Okay, so y plus 4 equals -4/5 x plus 4/5 plus 4/5. Okay, now what?
Minus 4.
-4. Well, let's see. If you multiply it, you got to multiply it by 5, right? So it's what, -25. Wouldn't it be -16/5? And you wanted me to trust you.
What it'd be -3.
Oh.
That's the whole.
Oh, okay. All right. I see what you're saying. All right, so that's step number 2. What is step number 3, Zamira? Okay, so set them both equal to each other. So we have 5/4 x minus 1/2 is equal to -4/5 x minus 16/5. I think this is probably one of those good opportunities to multiply by something that's going to get me whole numbers, because if you'll notice all through here, they're all fractions or decimals. So the common denominator really between all of this is probably, what, 20? So, let's see what we get if I can rewrite all that. 5/4 times 20, that's going to be 100 divided by 4. 100 divided by 4 is 25. Is that right? So we get 25x here. -1/2 times 20 is going to be what? -10. Okay. -4/5 times 20, that's -80 divided by 5. What is that? 16. So we get 16x. And what is -16 times 20 divided by 5? It's taking off on me because the bell's going to ring.
Well, I'm usually late if I don't leave right away.
What did we get out of that? Just so we can at least finish this portion. 64? -64? Okay. Thank you. Okay. And so we probably won't have enough time to finish that, but I might finish that with the other class. I'll pick it up with there for them. So I'm going to hit stop.